In the vast and endless expanse of the universe, amid the countless stars, a singular thought emerges from the darkness of space. What if the key to life on Earth didn't originate here at all? What if instead, the story of life begins not in the warmth of our own planet, but in the cold, rocky reaches of space? Could asteroids, small remnants of a bygone era, be more than just remnants of a chaotic solar system formation? Could they, in fact, be the very vehicles that transported the seeds of life to Earth? And could they, perhaps, carry life to other worlds still waiting to be discovered? The universe, as vast and empty as it may seem, has always carried with it the potential for creation, an intricate, delicate dance of elements and compounds, waiting for the right moment to give birth to something greater. Asteroids, these rogue travelers of the solar system, have long been regarded as lifeless, barren rocks, drifters of cosmic debris. But what if they have always carried more than meets the eye? The idea that life on Earth could have originated somewhere else in the cosmos and found its way here through the impact of an asteroid or comet is called panspermia. This hypothesis suggests that not only organic molecules like amino acids and simple sugars, but even life itself, could have made its way to Earth from distant parts of the universe, hitching a ride on asteroids or comets. It's a bold and radical theory, one that challenges our understanding of life's origins and implies that life could be far more widespread than we ever thought possible. Imagine the Earth billions of years ago, hot, volatile, and constantly bombarded by asteroids, meteoroids, and comets. A young, evolving planet, its surface battered and scarred by constant impacts, its atmosphere thick with the gases of creation. The conditions for life, as we know it, hadn't yet come into being. But amid the chaos of this early solar system, somewhere out in the cold, distant reaches of space, asteroids were already being shaped by the forces of the universe. These space rocks had traveled across light years, passing through the remnants of exploding stars and the birthplaces of new worlds, carrying with them the chemical ingredients that would one day give rise to life itself. Asteroids, while appearing to be mere chunks of rock, are in fact incredibly complex. Many contain traces of organic molecules, amino acids, fatty acids, and even sugars, compounds that form the very building blocks of life. In 1969, the Murchison meteorite, a piece of an asteroid that fell in Australia, provided scientists with an astonishing gift: the discovery of over 90 different amino acids. Some of these amino acids are the same as those found in the proteins that make up living organisms on Earth. This discovery suggested that the raw materials for life weren't unique to our planet. They were present in the cosmos, in the very space rocks that pelted the young Earth. But the real mystery begins when we ask, how did these molecules come together to form life? If asteroids could deliver the building blocks, what triggered them to assemble into something more complex? Theories suggest that the heat and pressure from asteroid impacts, combined with the unique chemistry of early Earth, could have catalyzed these molecules into self-replicating forms, the first glimmer of life. Or perhaps life was already there, dormant, waiting for the right conditions to spark its emergence. Could this spark have been provided by the very asteroids that impacted the Earth, their cosmic cargo a catalyst for the birth of life itself? But what if this is just the beginning of the story? The implications of panspermia stretch far beyond Earth. If life, or the building blocks of life, can survive the violent journey through space, what about the other planets and moons in our solar system? Could asteroids have seeded life elsewhere, on Mars, for instance, where evidence of ancient rivers, lakes, and possibly even oceans points to a once habitable environment? If life was ever present on Mars, could it have arrived via asteroids? And what of icy moons like Europa, Enceladus, and Titan, where subsurface oceans may harbor conditions for life to thrive beneath their frozen crusts? Could asteroids, bearing organic compounds, or even simple life, have delivered the seeds of life to these distant worlds? Europa, one of Jupiter's largest moons, is among the most intriguing candidates in the search for extraterrestrial life. Beneath its frozen shell lies an ocean, kept warm by tidal forces from Jupiter's gravity. Could this hidden ocean harbor life, or at least the conditions necessary for life? The discovery of water vapor plumes erupting from Europa's surface suggests that the moon may be actively exchanging material with space. If these plumes contain organic molecules, could it be that asteroids, crashing into Europa long ago, introduced the necessary compounds for life to emerge? Mars, too, holds a tantalizing mystery. A world that, in its distant past, may have had a much warmer and wetter climate, perhaps capable of supporting microbial life. Did asteroids play a role in seeding life on the red planet? Or could Mars have been a place where life arose independently, only to be wiped out by a shifting climate or a cosmic catastrophe? The question of Mars's habitability and whether it ever hosted life is central to our search for life beyond Earth. And if asteroids helped seed Earth, could they have done the same on Mars? As we continue to study Mars, NASA's Perseverance rover is gathering clues that may reveal the planet's ancient past. In 2020, Perseverance landed on Mars, tasked with searching for signs of past life and collecting samples for future study. If life once existed on Mars, these samples may hold the answers. Could the same life, seeds, molecules, or dormant microbes be found on Mars that once traveled to Earth on asteroids? Panspermia also opens up a grander cosmic possibility. If life can hitch a ride on an asteroid, then perhaps life has been spreading across the universe for eons. Imagine an asteroid striking a distant world, sending fragments of a planet's surface into space. These fragments could contain the seeds of life, organic molecules, or even microscopic life that could land on another world, far from its origin. Could this cosmic transfer of life have already happened on distant planets and other star systems? The implications of this cosmic seed spreading are profound. If asteroids can carry life or the building blocks of life, then the universe itself could be a vast web of interconnected worlds, each world a recipient of the same basic ingredients for life. As we search the cosmos for signs of life beyond Earth, we must ask ourselves, what if life, in some form, is more common than we ever imagined? What if our own world is just one of many that have been touched by the cosmic hands of asteroids? Looking back at Earth, we realize that the question of where life came from is not just a question of our past, but a question of our future. If asteroids can deliver the building blocks of life, could they one day deliver life to other distant planets? Could humanity one day become a part of this cosmic cycle, spreading life to new worlds, carrying the story of Earth across the stars? In the silent depths of space, asteroids continue their ancient journey, carrying with them the possibility of life. They are more than just space rocks. They are messengers, bearing the potential to transform worlds. As we continue to explore the cosmos, we may one day discover that life is not confined to Earth at all, but is part of the larger cosmic tapestry, woven together by the very forces that created us. Asteroids, ancient travelers of space, could hold the key to understanding life's origins, not only on Earth but throughout the universe. And in the search for life, the journey has only just begun.